you able to see the screen?
Yes, sir.
We started last class about the radio communication or
Sir,
wireless.
voice is feeble, sir. I'm sorry.
Voice is feeble. Okay. Now,
Now, okay, sir.
Okay, sir. Rombanella.
okay, we are talking about radio communication. I started with what you called as modulation. That is converting the signal which needs to be transmitted. Modulating means combining two things. Another thing, modulating or varying the. For example, when I talking, no, I may talk very low voice. Suddenly, I raise the voice. If I do that, changing my level of my voice, that is called modulation. Correct? While singing, people say modulation. Different voice is modulated. That means varying the intensity of sound, like that. In this case, modulation, what we are doing in radio communication, I want to transmit this signal. This is the signal I want to transmit. But most of the time, the signal what we wanted to transmit will be in the order of low frequency. For example, audio signal, note down. Audio signal frequency, we all know that physics, maybe 6, 7 we are told, 20 hertz to 20 kilohertz, that is 20,000 hertz. Okay. If TV signal, because we are taking a picture using TV camera, TV6 or video signal, TV or video signal, right? The video signal, the frequency range, they call a band or a spectrum or band is audio is 20 hertz to 20 kilohertz. But TV signal generally start from 0 to 5 megahertz. Correct? We know that when signal is varying, this is called a frequency. One cycle time is called as one over f. Correct? We can't. If I take this is cycle, correct? We say that if the sinusoidal wave, this is the starting point t equals 0. This is positive of cycle. This is negative. This is called as one cycle. Correct? The periodic signal. If you see your voice signal, I am talking. Correct? Already my microphone has converted my voice signal into electrical signal. If I use an oscilloscope, if I see the signal may be like this. It is not a fixed figure. This is single frequency, right? But my voice, I am varying tone. We call it tone. Tone. If I say the tone is varying, that means this frequency is varying. Within one line of speech, my frequency may vary from 20 hertz to maybe 5 kilohertz, 6 kilohertz. Correct? Higher the, for example, whistling. Correct? Whistling is high frequency. Correct? So, like that, the frequency is varying amplitude. This is called as amplitude. This is called as frequency. When we talk, my amplitude is varying, which we call a loudness. Correct? Or sound intensity. If the signal amplitude increases, this is called amplitude, sound amplitude. More signal, louder the voice, so the sound can reach a longer distance. Similarly, the frequency cycle, number of cycle happening within 1 second is called frequency. I told you, generally, the audio signal, when we talk audio signal, the frequency is 20 hertz to 20,000 hertz or 20 this one. Video signal, we are using camera, we are taking a picture continuously frame rate. Video signal frequency generally can go 0 to 5 megahertz, 5 into 10 power 6 hertz. Generally, it can vary anything. It is not fixed. Correct? Depending on the light intensity, the other parameters, the signal also will vary. How the signal will look, that's what I told you. The audio signal look like this. If I see the video signal will be very, very high, this is very high frequency. Within 1 second duration, millions of cycles varying in video, audio will vary up to 20 kilohertz. The frequency is varying, x-axis time. We know that f equal to 1 by t. Correct? Where t is nothing but one cycle time. This is called as capital T, cycle time. Correct? 1 over cycle t is called a frequency. Within 1 second, how many times it is varying? Okay. So that now, why we have to modulate, I will tell you. There are two things I could not tell in the previous class before going further. We know that in our communication systems, correct, in this one, radio communication system, I told you we have, for example, you have microphone. You go to TV station, correct? Microphone, a person is standing and talking. So the audio signal, sound wave is going, audio signal or sound wave is hitting microphone, right? When I talk, this signal is converted into electrical signal, correct? This is time. This is in the millivolts. This is microphone output. This signal is microphone output. Please see that it will be in the order of millivolts, correct? Maybe it will vary from 0 to say maybe 500 millivolts. That's what you will get, 500 millivolts. That signal cannot be directly broadcasted by radio. In radio station, when some person is talking, that is picked by phone, this microphone converts audio signal, which is a pressure wave, sound to pressure wave, correct, is converted into electrical signal. This is an electrical signal. This signal is millivolt. So it will be further amplified. You need an amplifier, correct? We say the audio system, correct? When you want to have some music party, you have a microphone. From that, there's a amplifier, electronic circuit. From here, the signal coming in millivolt, that will be amplified into maybe hundreds of volts to thousands of volts. In case of, for example, in auditorium, the millivolt signal coming from microphone will be converted to hundreds of volts. Then it will be given to a speaker. It will be given to a speaker, correct? Maybe 100 volts. 0 to, say for example, 0 to 1000, 0 to 1000 millivolts. That is what the microphone is picking, depending upon by voice level. That will be converted 0 to 100 volts by the amplifier. Sometimes they call it power amplifier. They call it a power amplifier. What happens? The millivolts is converted to volts, and also the microphone gives current in the order of milliamps or microamps. The microphone also generates current, and not only voltage, there's a current also it generates. The current will be in the microamps or milliamps. That is not sufficient to drive this speaker, correct? Speaker, what is the power? Power equal to voltage into current. I told, say for example, 500 millivolts. 500 into 10 power minus 3 is the volt, correct? V, which one? Microphone signal. I say Vm. What is Im? Microphone current, maybe 500 microamps or 5 milliamps. I say the 5 milliamps, even that is a big number, right? That's what it generates. What is the power generated by this electrical power? We take that 5 milliamps. So that means P microphone equal to V microphone generated by I microphone. So that is not 500 into 10 power minus 3. This multiplied by 5 into 10 power minus 3. I'm talking milliamps. 5 into 10 power minus 3. 10 power minus 3, that means we know that 25 followed by this one multiplied 10 power minus 6 watts. Correct? So you can see that this will become milliwatts. Right? So there is minus 6. So that means 0.25 into 10 power minus 2 watts is nothing but few milliwatts. If I give the few milliwatts power generated by the microphone to a speaker, the speaker will not work. It won't make sound waves. It needs more power, at least in the order of hundreds of milliwatts or hundreds of watts. That's why we have an amplifier. Correct? Music system you have, no? In your home also. That is called power. There, what is that? The millivolts will be amplified to volts. 0 to 500 millivolts will be amplified 0 to 50 volts or 0 to 100 volts. And also it amplifies current. The milliamps current will be amplified maybe 0 to 5 amps. So what is power? The output power amplifier. I say P power amplifier, correct? PA equal to say that 100 volts and current IA. I'm showing the maximum current is, for example, 2 amps. That's what the amplifier. That's why we call amplifier. What is job of amplifier? It is going to amplify the electrical signal generated by any sensor. Microphone itself is a sensor. Please note it is a sensor. What is job? Sensor. Next semester or next year, maybe next semester you are going to have. Okay, one more thing. Your classes for next semester will start from January 10th. January 10th, next semester class starts, because yesterday we had a meeting, coordinated meeting. So your classes for next semester, 2 subjects, correct? One is for IC engine, combustion and pollution, one course. Other course is vehicle dynamics. These 2 courses will be taught by 2 more professors next semester. It starts from January 10th class, correct? So After that, later I am going to talk mechanical. That time we'll talk about sensors. Just I want to tell you, but I want to tell you now itself. So the semester for next this one will start from August 10th. Plus or minus 1 day will be there, tentatively. This is what yesterday decided. Okay, by the our chairman. We met chairman because we have more than 6-7 courses. We all met 2 days before that time. Just I wanted to pass the information. Okay, but when we talk about mechatronic course, when I teach, definitely I am going to teach. That time we will talk about sensors, all those things, modeling sensor, all many things we are going to talk. Okay, now power amplifier amplify the microphone signal into millivolts into volts and also amplify current in microamps, milliamps to amps. Right? Then it is given to speaker. So the power is nothing but 200 watts. 200 watts of power will be delivered by the amplifier to the speaker. Speaker convert the electrical into sound waves again. That's what is speaker. So you are able to hear. Correct? So loudly you can hear. That is in case of your music system. But in case of I told you when we talk about radio station, FM radio, all those things. Again, you have the microphone. I say MP. There's a person is talking and sound wave is hitting. This signal will go to an amplifier. Right? From millivolts to milliamps, this will amplify to, for example, hundreds of volts, 100 volts. I'm talking, see, 0 to 500 millivolts is the voltage. That's what your microphone generates, depending upon my loudness. If I talk very low voice, it may generate some 100 millivolts. If I talk louder, it may make 500 millivolts. If I talk still louder, it may make 1000 millivolts. That is what amplitude I told you, correct? This is called amplitude. This amplitude vary from 0 to millivolts. I say 1000 millivolts or 500 millivolts, depending upon the sensitivity of the microphone. Correct? Even if you want to pick very low noise, you have to pay a higher price. There are microphones, even very quietly somebody talking. Correct? There are sound, you want to measure quietness of the room. Correct? So fan rooms, some small insects making all the things you want to pick up, you have to buy sensitive microphone. Sensitive microphone can amplify even very small sound, very low level sound into hundreds of millivolts. Okay? So that's one thing. So this will be amplified to hundreds of volts, 0 to 100 volts. Correct? When input is 0 millivolts, the amplifier output also 0 volt. When input is 500 millivolts, the amplifier output go to 100 volts. What is gain? When we talk about amplifier, we always talk about gain. What is that? Amplifying is increasing something. Gain of the amplifier. Please note that all this thing we are going to talk about mechatronics, designing amplifier, filter, electronic circuit filters. We are going to cover many the microprocessor, programming, microcontroller, embedded control programming. Many things we are going to see in mechatronic course. Okay, that will come in the 3rd semester, something, or 4th semester. Okay, gain of the amplifier is nothing but output voltage amplifier divided by input voltage. Okay, I said maximum, we take maximum output only 100 volts. 100 volts is nothing but 1 lakh millivolts. Correct? Divided by 500. Okay, 500 input millivolts. So what will happen? This I will say 2, and this 0 will go. The gain of this amplifier is nothing but 200. Is going to 200 times. So the amplifier is going to amplify 200 times. What is going to input electrical signal into again electrical signal? That is given to speaker. But in case of radio station, I want not in hundreds of watts. I may need kilowatts or megawatts, because I want to transmit the signal through an antenna as a radio wave for longer distance. So already we saw radar, correct? Radar transmission range. We talked about transmission. Do you remember? Antenna gain, power of the transmitter, correct? How much, all these things, same thing here only. So 100 volts is not sufficient. You have to amplify still further. So in radio station, you will have one more amplifier, which is called as high power amplifier. This itself they call power amplifier, PA. This they call high power amplifier. One more stage. What that will do, the 0 to 100 volts will be amplified to 0 to 10,000 volts. then it will be given to antenna. It will be given to antenna. Okay. But before giving to antenna, what they do is they will add one more signal, what we call a carrier signal. In power amplifier, they add carrier signal. That's what this. Please see here. I am circling. Carrier signal will be mixed with the, this is the signal, audio signal for microphone, for example. A single frequency component will be added this one. Then the output will be amplitude modulator signal. Already we saw this amplitude modulator signal. That signal is given here. AM signal, modulator signal is transmitted as a wireless signal using a big antenna. What is the power output here? Here we are giving 0 to milliamp. This will be 0 to 2 amps. What is the high power output? This one 0 to 10,000 volts. Voltage amplified. Current will be amplified 0 to maybe 200 amps. In radio station, what is the power of the radio station? Correct? I say RT, radio RS, radio station final output is nothing but 10,000 volts multiplied by 200. How much is? 2 followed by 6 zeros. That is 2 megawatts. 2 megawatts the power, this amplifier. So if I have 2 megawatt power, my radio will be heard up to 1,000 kilometers. Any amp radio within 1,000 kilometer radius can hear. They can pick the signal, they can hear. Correct? They are public, they are all radio station, TV channel, public broadcasting. Correct? So we want, the government wanted to, or your radio station wanted to reach many people longer distance. Any radio or TV receiver within the 1,000 radius can pick the signal, they can see the so that is right. So we are amplifying. Correct? So before that, we'll modulate. Correct? Now, one thing I want to tell why I'm talking this is, we know that actually what I want to transmit my voice signal or the TV signal, which is picked by the microphone or a TV camera. Correct? TV camera. That signal only I want the reach the user who is away 100 kilometer, 10 kilometer, 10,000 kilometer, 5,000 kilometer, whatever it may be. Right? I want to reach. But if I want to transmit the signal using it, I say I find a stage, so I have the high power amplifier of my radio station, TV station, which is connected to an antenna. Correct? So I am giving here carrier signal and here my audio signal. And here is modulation is happening. Okay, don't worry, just understand only. Now, this will be converted into radio signal by the antenna. Antenna, if you supply high voltage, high current, it automatically radiates. Antenna radiates automatically. Your cell phone also, there is an antenna. When you talk, that is signal is picked by microphone in your cell phone. In microvolts, millivolts, it will be amplified, and there's a modulator. That modulator modulates and gives to your antenna inside your cell phone. Very small antenna is there on the printed circuit board. Okay, and that antenna automatically radiates your modulated signal. Here, amplitude modulated signal, AM modulated signal is sent, broadcast as RF waves. This is traveling in the space and picked by this one. Okay, now the size of the antenna. I told you what is antenna. Antenna is a conducting rod. Correct? On your motor, your car, on top of the car you have antenna. Correct? Radio antenna is there. Correct? What is it? Nothing but a conducting rod. Correct? A stiffer rod so that you won't bend this one. You can do. So now basically, if I have a conducting rod, note down. If I have a conducting rod made of any material, it should be a conductor, copper, aluminum, gold, platinum, but it is a conducting material. It is an electrical conductor. Now, if radio wave comes and hit, this is my radio wave. Right? It comes and hits this. This is my antenna. Antenna is nothing but my wire, just a wire. Even a very thin wire also working. Only thing is, if a thin wire bend is flexible, no, so it needs a stiffer because you want to put over your vehicle or over your car, over your this one radio. That's why there is over this one. Now, it hits means automatically an electrical voltage is induced. Electrical voltage is induced. automatically. When it hits in this wire, correct, in the rod, electrical voltage, that is called as Maxwell law. Maxwell law, and also Faraday's law. There are two laws are there. If an electromagnet, this is EM, radio is nothing, electromagnetic wave. If it comes and hits a conducting wire, it can be very thin wire, micrometer diameter or 1 meter thickness, no problem. But main thing is it should be a conducting wire and length. It has a length L, right? So then it hits means then it induces a voltage, right? That voltage, the amplitude of the voltage, picked voltage or picked signal, radio signal depends upon this length of the antenna. Longer the antenna, it can pick more signal, then signal will be stronger. Okay. For example, you are in Pune, correct? You are traveling from Pune moving to Bombay. Correct? In Pune, there may be FM radio station, AM radio station. You tune to a station, while driving car, you are listening. As you go away from Pune, you can see that sometimes signal will come, the station will pick and just will drop. Correct? So when you, from this my antenna, as I move away, right, the signal strength become weaker. So there are two. One is transmitting antenna, other one is receiving antenna. RX antenna, this is transmitting antenna. Transmitting antenna fixed on the TV's radio station. It is sending radio waves. Now, as you move away, the amount of signal pick become weaker. If I want the station to pick, what you do? Have you seen that you will go and pull out the antenna length? Generally, the foldable antenna, because you will pull the antenna longer and longer. But what output, it may be 1 meter, 2 meter. That is the maximum length you can pull. Correct? That means longer the antenna length, it can pick more signal. Then signal strength, we call it signal strength. Correct? From few millivolts, it becomes tens of millivolts. Then your amplifier inside your radio can amplify and you can listen to music. When your car goes far away from this one range, we call a range of the station, then it won't pick. Correct? Same thing, only we are talking. Okay. Now, the length of the antenna also depends upon wavelength. L is the length of the antenna. Correct? What should be length of the antenna to pick a signal? Correct? There's a formula. Longer, if this is the radio wave length. Correct? This is radio wave length. Radio wave length. Okay? This is antenna length. There's a relationship. Okay? So, if this radio wave length, correct? Radio wave length, lambda is proportional to frequency. Already we know. What is lambda equal to? Yesterday, last class I told.
V into lambda is
C by F.
F. Yes.
Correct? The transmitter signal lambda wavelength, it is called wavelength or radio wave wavelength, depends upon the frequency. For example, this F equal to, I say, 1000 hertz. Correct? We know the C equal to 3 into 10 power 8 meter per second. That is speed of light. So, what is the lambda? Lambda equal to 3 into 10 power 8 divided by 1000. That is the signal. Now, we know that automatically 3 into 10 power 5 is the lambda. So many meters. That is radio wave, this one. We know that if this signal to be picked, correct? So, the length of the antenna, L, should be at least 10 times. Correct? There's exact formula. I will tell you what it is next class. There's a minimum length. So, why I'm talking is, if my signal, what is my voice signal? I said 20 kilohertz. 20 kilohertz is the maximum frequency. Lowest is 20 hertz. Okay, then what will be wavelength of this 20 hertz signal? Lambda equal to 3 into 10 power 8 divided by 20. Correct? So, it is going to be 3 into 5 into 10 power 6 meters.
Sir, but that is we'll have to consider speed of sound in our media, right? Like
We are talking about radio signal. Are you transmitting radio signal or?
no. Like you, since you said the 20 to 20,000 kilohertz, like
Is
that's the
Ah,
okay.
that was this.
Hmm.
Okay, this
Okay.
signal. If I directly wanted to transmit using a radio, if I convert directly, modulate it, no modulation, directly. What I'm saying is, I have microphone, then a power amplifier to antenna. Okay, here 20 to 20 hertz, 20,000 hertz. Okay, this is my power amplifier. I said 100 or even 1000 volts. I amplify. I said 200 amps. But this is my antenna. Now if I want to transmit properly, the length of the antenna depends upon the wavelength, lambda. If the 20 is the wavelength, frequency f, what is the wavelength? If the 20 hertz is signal you want directly transmit, 20 hertz I want to transmit. What will be the wavelength? Lambda.
1.5 into 10 to the power 7.
You see what I said 10 times or 10 times, correct? Should be the antenna length, correct? 1 minute. I just the antenna length. There's a formula. I will tell you next class. Okay. So they say minimum half wavelength is better, correct? 1 lambda by 2 should be the antenna length for good reception. Okay. Now, what should be the antenna length if I directly transmit 20 hertz?
It will be kilometers, sir.
Not possible, right? That is why what we want to do is we will convert this 20 hertz signal with a high frequency carrier. Please note that carrier frequency will be 100 to 200, 1,000 times more than the signal frequency. 1,000 times. Okay. Many times we know that radio station, it can be higher. Okay. What is radio station? We say it's a 500 kilohertz radio station frequency. When I say 500 radio station frequency, what we are talking is this carrier signal. Correct? This is called as a carrier. Please note the why we are calling carrier. This signal will be put over this, and this carrier is converted into this. This is what your signal. This is the carrier signal. If I connect the peaks of the carrier, modulated this one, that is nothing but this signal. But what we are transmitting is only carrier, not this signal. Okay. My station frequency, I say 500 kilohertz. Okay. What is lambda for this? 3 into 10 power 8 divided by 500 into 10 power 3. Okay. What will this is 2, this is gone. So you have lambda equal to 3 into 10 power 3. Correct? Divided by 5. How much is that?
600.
600 meters. Right? We said that minimum the antenna should have half of that length. This is lambda by 2 should be the length of the transmitting the radio station. That's why you go and see the radio station, you'll have very long, like a tower-like structure, right? Something like this. This may be 100 meters, 50 meters, something like that. Long. This is called transmitting antenna. Okay. Receiving antenna can be smaller. Okay. But still it is bigger. In your cell phone, what is the cell phone frequency? Already we talked, right? We talked about cell phone frequency. What is this one? Frequency spectrum. Mobile phone.
Very high, sir. I think it is.
See here, 2.4. Gigahertz.
Gigahertz. Okay.
Correct? Correct. That is the spectrum they are using, 900 to 1 megahertz to 2.4. Even if you take, 1 gigahertz to this one. So if I say the 1 gigahertz, what is the lambda? Lambda equal to 3 into 10 power 8 divided by 1 into 10 power 9. Okay. So this will become 3 into 10 power minus 1 is nothing but 0.3 meter. Correct? 0.3 meter. Okay. But most of the time we transmit around 2-3 gigahertz also. So still this will become smaller. That's why the cell phone antenna, inside your cell phone you have smaller antenna. Correct? I said that 10 times smaller is sufficient for receiving. For receiving antenna can be much smaller. That means 0.3 centimeter is sufficient. Correct? That is nothing but 3 centimeter. Correct? So very, very small. So that is why we have to do modulation. Why I am explaining why we are doing modulation. If I directly transmit the signal, the antenna length will become bigger. Okay. If I wanted to that's why what I do using modulation, the actual signal is converted to a modulated signal, high frequency carrier that is broadcasted. Okay. So the broadcaster signal is this. This is signal we are broadcasting. Any doubts in this?
Sir, one thing I want to ask, how this, like what I'm going to say, modulating wave is carried by the carrier in that way?
Yeah.
What is the...
No. We are transmitting this. This is the modulated wave here. Please see the peaks. See, originally the modulated, this was the carrier. So this was, say, for example, 1 gigahertz, your cell phone signal. Carrier. This is carrier signal frequency. Same signal only now. Please see that this and this is combined. These two are combined. When I combine, I get this. This frequency also is same. This is called modulated carrier. Please note that this is called modulated carrier.
There will be a multiplexer, right?
No, multiplex is not needed. Multiplex,
Okay, sir.
if you want to have multiple channels. We are talking about only one channel, means what I am doing is, this is called amplitude modulated. Carrier is amplitude modulated. I told you there is a phase modulation, correct? This is FM, frequency modulation, correct? This is frequency modulation, this is amplitude modulation. What I am doing is, I am modifying amplitude of this carrier exactly like this. This is same. Are you getting? Okay, let me draw.
I think Roshan sir's question was on the mathematics of how two waves are being synced together. If I'm right, sir.
Right.
Then modulating equation, there's an equation because basically the sinusoidal wave, correct? It is a AC signal. We can write the equation. Okay. Next class I will tell you. Let me complete some portion, then we'll talk about it.
Oh, sorry. No problem, sir. Please.
So main thing what you have to note down is the antenna length is proportional to lambda. Correct? If I directly try to transmit low frequency signal, note down this. Low frequency signal, the lambda will be bigger. Lambda will be very big. Correct? In this case, antenna length also needs to be very big. Antenna length has to be very big. Impossible. We are talking about 500 meters, 2 kilometers, 3 kilometers antenna length. Correct? When I say 20 years, 50 years, directly if I am trying to transmit. So I cannot transmit, I cannot receive. Correct? So that's why what we do is I take this input, this signal, and I modify a carrier signal which is higher frequency. Carrier is higher frequency. Higher frequency. Correct? I talk in the hundreds of times, thousands of times higher than the input signal. Okay? So the carrier is modified. What we are transmitting only carrier, not this signal. This is carrier high frequency. The carrier amplitude is modified. Right? Before modifying, let me show you another waveform. So this is my carrier, this one, carrier signal. Okay. Then I have my input signal. This is what I wanted. Actually, this is my signal wanted to transmit. Okay. Now what I'm doing is I am transmitting modulated. Modulation means what I'm doing. Please see it, then you will understand. This carrier, this amplitude, one minute, just I want to draw it properly, you will understand. Okay. Please see that this is the carrier, correct? The same carrier, the amplitude is varying. If you see the peak of the amplifier input, the signal is nothing but this. That's why they call amplitude modulated carrier. Amplitude modulated carrier, AM. AM station means this is my signal. This I wanted to transmit. If I transmit this low frequency signal, I need bigger antenna. Both transmitting. Instead of that, what I do, I combine this signal with this carrier. What I get is this amplitude, but this is the amplitude model. What I am transmitting is not this, not this. I am modified the this amplifier, the carrier amplitude I modified. And this is high frequency, correct? Same high frequency I am transmitting. So what I do is smaller antenna is sufficient. Length of the antenna can be smaller. That's why we do modulation. Because most of our input signal, video signal, audio signal, or digital data is in the order of kilohertz. If I want to directly transmit, the low frequency, bigger antenna is needed, longer antenna. Bigger means length of the antenna. Sometimes kilometer length, not possible, very low frequency. Right? In that case, at least hundreds of meters. Now, if I amplitude do a modulation, what I'm doing, I take a very high frequency signal, carrier, and modify its amplitude. This is called amplitude, correct? So the amplitude is modified. And I transmit the carrier, which is 100 times, 1000 times higher frequency. So my antenna length will become smaller.
So does it mean that, sir, after the transmission is done to the required destination, these waves will be again separated out?
That is the demodulation. In your TV, radio, cell phone, antenna, you have an antenna, correct? But then it comes to demodulator. First thing is come to an amplifier, because we know the signal picked is millivolts or micro, because your antenna is very, very small, few centimeters, right? Few centimeters. I told you the signal amplitude depends on the length of the antenna. Your antenna over your car is only 1 meter, half meter, 1 feet. In your cell phone, few centimeters. So picked signal will be few microvolts. That will be amplified. They call pre-amplifier. From microvolts, it amplified to millivolts. Again, there will be one more amplifier, power amplifier. Correct? That will amplify to volts. Not this one, maybe 10 to 100 volts. After that, you have demodulator. We'll have demodulator. Correct? Demodulator will separate your signal. Signal will be separated. And again, finally, it may be amplified and given to speaker or your screen. So inside your TV, cell phone, radio, there's a demodulator, which removes the carrier. This is the carrier. What do you want? You want only this peak. Correct? This peak alone is picked. It will be removed this high frequency. Finally, you will get this. That is the demodulated job. From the received amplitude modulated carrier, the carrier will be removed, and the signal, this is, I will say red color, this is called signal peak, that will be amplified, given to speaker. It happens your cell phone, TV, everywhere, because your signal is low frequency. To transmit signal, you need bigger antenna for transmit receiving. To avoid that, what I'm doing, I am mixing the signal with a carrier of high frequency. I am transmitting only the carrier whose amplitude is moderate or the frequency is vary. Again, this is carrier only. In FM, what I do, I am varying the carrier frequency, not amplitude. You see the carrier amplitude. This is what you are transmitting. The amplitude remains constant, but its frequency is varying. The frequency variation depends upon, please see here, depends upon this. This is signal. This is a carrier. See, carrier is a constant frequency, correct? Everywhere, cycle time is same. This is constant amplitude, correct? And the constant frequency. Frequency also constant carrier. In FM, what I am doing, I am keeping the amplitude constant. I am varying the frequency. The variation of carrier frequency proportional to this signal. This is what is transmitted by the FM radio station. In your FM radio, the received signal is this, right? That will be amplified, microvolts will be amplified, and this carrier is removed. Finally, you will get back this. That is called demodulation. Same thing case in the AM. Instead of varying the frequency, you can see the frequency is same. Frequency remain constant, but amplitude of the carrier is varying. Correct? Carrier frequency constant, amplitude, that's why you call AM, amplitude modulated. This is called FM, frequency modulated. What actually station, TV, including your cell phone, inside your cell phone, both you have. Receiver also is there, transmitter also is there. Inside your cell phone, you have a modulator and also demodulator. When you talk, your signal picked by this one and amplified and modulated using a high frequency carrier. That is what transmitted to the another cell phone tower. Correct? When somebody is talking to you, your cell phone picks the signal. That signal is amplified, demodulated, given to your screen, also your scan. This is how the radio transmission happens. What is this one? This one. See, I talked for at least another 20-25 minutes. What did you understand now?
We got it.
Need for modulation. What is that you understood?
Sir, you have told that basically there is a base signal which is to be transmitted to destination.
Correct.
Now, since the base signal is having low frequency,
Correct.
so to modulate that, to transfer that, we'll need a very big antenna, which is unrealistic in that sense.
No, without modulation. If I transmit without modulation.
Without modulation. So basically, then what is it?
Antenna, antenna both should be very, very big.
Right, sir. Right, sir. So
That's
basically,
possible.
to transmit that, we combine it with a high frequency like carrier signal, and then it is being transmitted to the destination.
Yeah.
Where demodulation happens, and the peaks of the what I meant to say resultant wavefront is taken, which is the
received modulated carrier. This is what is separated.
right.
So the carrier is removed.
Right, sir. That is understanding that we have got.
They was signal and given to speaker or TV, video signal given to screen.
Right.
Cell phone, all this. This is what happens. The key point is the antenna to modulation done only to reduce the size of the antenna, practical size, including a cell phone few centimeter possible. That is why cell phone, the transmitting frequencies in gigahertz. Right? Cell phone, original cell phone, they were transmitting in megahertz. Motorola when made 30 years before, the cell phone, I have seen the cell phone, correct? First cell phone 30 years before, which was imported by Motorola. It is called a brick. The size will be 1.5 feet length, correct? Width will be few centimeter, correct? Depth will be few centimeter, weighing around 2 to 3 kg. And it may look like, in fact, their nickname for the original Motorola cell phone, they are keeping in the This one, company headquarters in the display. First cell phone what they made, demonstrated. They call it, nickname is brick. Correct? The antenna may be something around 2 to 3 feet to antenna like a T. This one. Because they were transmitting that time in the order of the carrier frequency that time it's over 500 megahertz only, radio TV station. Gigahertz transmit did not start that time. Now, do you want a compact inside a packet, all those things, nothing should be visible. That's why now broadcasting, cell phone signal broadcast in the gigahertz range. Correct? TV, all those things, we are transmitting in the order of megahertz. Still, the length of another 2 feet, 3 feet, 5 feet radio. Correct? On your car, all those things. Correct? Because there, the radio signal transmitted, I told you, kilohertz. Correct? 500 kilohertz to 3 or 30 megahertz. AM. FM means 88 to 108 megahertz. Still, this one, radio, TV, all those things need antenna like that, 1 feet, 2 feet, at least foldable antenna you need. But cell phone also will be bigger, foldable antenna there, 1 feet, 2 feet, 3 feet antenna. Carrying is difficult. Correct? So that's why they started transmitting in gigahertz. So antenna now is not visible at all. Inside your cell phone, in the what you call printed circuit, but there's a copper track. Correct? On the where all the ICs are there, there's a copper track in a spiral fashion. Copper track in the inside your cell phone PCB, printed circuit board. That is sufficient, few centimeters, because we are transmitting gigahertz. That's what I want to tell. Okay, fine. Now we talked about digital transmitter, different type. This one, frequency model FSK, whether digital signal or radio signal, you are doing modulation only to reduce the size of the antenna. Most important critical point. Modulation needed only for that, so that you can transmit to and receiver's antenna can be smaller. Transmission is also okay, at least you can get only one fixed. Radio, TV, all those things cannot have longer this one, because I remember, you don't know, we had a Philips radio in my home. I'm talking 45 years before or 50 years before. Correct? Philips radio over my house. There'll be 25 feet long pole on which there's no wire antenna. They sell Philips radio to receive signal. The antenna side over my house was 30 feet length. If the antenna is there, I cannot hear radio, because they were broadcasting the radio station 500 kilometers, 300 Chennai, 300 kilometers Bangalore, so 400, 350 kilometers. So Hyderabad, Delhi, all those things if I receive, I need the radio antenna 30 feet length over my house. Right? Long wire. Right? That was antenna.
So that means you belong to a rich family, sir. It seems.
Sorry, I cannot say that. Yes, in my whole village, only 2 houses had the radio 50 years before. First radio was bought by my father. I'm
sorry, sir. It was just a poor joke. Sorry.
Yeah, nothing wrong in it. But what you said is correct. But at that time, it was very difficult, very costly. The radio cost 300 rupees. It was imported from Holland. 300 rupees, Indian rupees that time, imported from Holland. Only 2 radio in my whole village. Nearby town, 10 people had radio. Still, I remember when I was doing first standard. That is 1970s beginning something. No, my main is not that. I said long this one antenna was over my house to receive the radio station, because all these stations were transmitting in the 500 kilohertz, 700 kilohertz, correct, 800 kilohertz, less than 1 megahertz, India, correct. All the Akasavani they call. Fine. Now we'll got it. Fine. That is not this one. We talked about, yeah, just 1 minute before talking, we already completed this, correct? Radio communication. Wireless, why you need wireless communication? This point I talked last time. I think last slide was this. Vikas, is that incorrect?
Yes, sir. This was the last slide we stopped. Last class.
Yeah, radio communication can be point-to-point communication. That means like walkie-talkie or cell phone, correct? 2 persons only talking, correct? One phone 1, phone 2, there's an antenna, you are transmitting, and here he is receiving, or this way or this way. He may be transmitting point, they call point to point, still wireless. But TV station, radio station is called point to multi, correct? Point to multi point, or broadcasting, public broadcasting, correct? One transmitter, millions of receiver, more than one receiver, it can up to millions of radio, millions of this one, correct? That is called as this one. For that, you'll be using this. Okay. Now let us come to, I think we'll give a break.
Yes, sir, we can have a break. We can have a break, sir.
Thank you.
5 minutes. After 5 minutes, we'll join, sir.
Definitely. Thank you.
Thank you very much. Sir, we can start, sir. Hello. Hello. Sir, we can start, sir.
Yeah. Okay, Mr. Roy will start.
Sir, we can start.
So, as per autonomous vehicle or automobile is concerned, the communication, there are three kind of technology are used. One is called Zigbee. Other one is called Bluetooth. Third one is Wi-Fi. There are others, but these are very popular. Okay, for vehicle to vehicle communication, vehicle to infrastructure, because vehicle is moving, you can use only this one. First, we will see what is Zigbee. Already, previous class I told you it is developed by a consortium which is called as Zigbee Alliance. Right? It is a license-free device in ISM band. Okay, they call it ISM band, where the carrier frequency should be 2.54 gigahertz. That means all the voice signal, data, the computer to computer signal, anything, whatever you do in Zigbee, generally it is for digital communication. The carrier, this is the carrier frequency. Just now we talked, if you are transmitting, you need a carrier on which the signal will be modulated. It can be amplitude modulator or frequency modulator or phase modulator. There are three types of modulation. Can be anything. Each one uses a different type of modulation. Correct? Zigbee uses one type, and Bluetooth uses another type, Wi-Fi uses another type. Whichever use, they say, as I told, it can be amplitude this one. And in digital, this one already told. If you talk about digital, we talk about three types: amplitude shift keying. In radio, TV, it called amplitude modulation, frequency modulation, phase modulation. In case of digital data transmission, correct, where you are sending binary number zeros and one, it is called as amplitude shift keying, phase frequency shift keying, and phase shift keying. Because digital data has only two things: high or low. Correct? Like this. This is high. This is low. This is represented by 5 volts. This is represented by 0 volts. This signal only you want to transmit wirelessly from one car device to another device, one car to another car. Correct? So that means that's what is shown here. Already I showed that this is data I want to transmit as a number form for understanding. Computer doesn't number 0, all these things. So it represents a voltage. Right? 0 volts and 5 volts. 0 volts and 5 volts. The first bit 0, 5, second bit, third bit also 5, fourth bit 0. This is what the inputs. This signal only you want to transmit wirelessly. What you are doing, I am going to combine this with carrier. This is my carrier signal. This is very, very high frequency. Very high frequency. In case of ZigBee, what is the frequency? 2.4 into 10 power 9 hertz or 2.4 gigahertz. What is this frequency? Maybe in the kilobits or megabits. At the most, what is this one? We talk in some megabits data. But here, the carrier frequency is very high. Okay. Now, if I combine these two, it can be amplitude modulated. Please see that this carrier is a fixed amplitude. Correct? In this case, whenever, what is first this one? 0. Right? You are going to transmit 0. What happened? The amplitude of carrier. See, this is the full height. Half of the height only transmitted. Correct? During this period, what is the amplitude? This is carrier amplitude reduced. When I want to transmit 1, what I did? The carrier amplitude went to full height. Correct? Full height. Again, I wanted to transmit next bit of height. Carrier is the full height. See the height of this one. Then this is 0. Again, the carrier is reduced half. Again, last bit is full. So what? So this is called amplitude shifting. The amplitude of the carrier was shifted between 0.5 and 1. Whenever you wanted to transmit 0 bit, the amplitude of the carrier reduces half bit. Correct? This may be for example 10 volts. This will become 5 volts. If this is 100 volts, this will become 50 volts. 0. Correct? So the carrier amplitude. The carrier amplitude from 1, for transmitting 0, it reduces half. For transmitting 1, it is full amplitude. Since amplitude is varied, because shifting, that's why we call amplitude shift keying. Amplitude of carrier is varied according to what data? 0 or 1. Correct? So accordingly, the amplitude is reduced or cell as a full amplitude. This is called digital amplitude, this one, modulation. This is called, please again, same thing only. For low frequency signal is converted to high frequency carrier amplitude modulation. This is given to an antenna, transmitted between a vehicle. Again, it is received, demodulated, and you will get back this signal. That's how happens this one. So instead of that, if I wanted to frequency shift keying, like it is FM, correct? So you can see that whenever I want to transmit 0, this is my carrier frequency, because you can see that this and this is same, frequency is same. When I want to transmit 1, it become half. Correct? That the frequency increased twice. Correct? Because you can see that the 2 cycles are there within same duration. The frequency of the carrier is doubled. Again, when I want to transmit, again it is doubled. The original, correct? Originally, this one. For 0, I am setting original frequency. If I want to transmit, the frequency has doubled. Please see that. That is very important understanding. Again, this is 1. This is also doubled. This is 0. Again, I want to transmit 0 means original frequency is transmitted. Again, I want to transmit 1 means frequency is doubled. So this is called frequency shift keying, similar to FM. FM is in radio. In case of digital transmission, we call shift keying. The frequency vary only 2 level. Because I want to transmit 0 or 1 only. Correct? In the voice signal, the frequency varies from 20 hertz to 20 kilohertz. Here only 2 frequency, correct? 0 or 1. That is for this. Similar phase shift keying also, phase is varying. Please see that the amplitude remain constant, but this is called phase, correct? This is a positive cycle like this. For transmitting 0, for transmitting 1, I am transmitting like this. Again, for transmitting 1, I am transmitting this. For transmitting 0, I am transmitting this. The phase is varied, correct? I call phase shift keying. So Bluetooth, correct, Wi-Fi and ZigBee may use amplitude shift keying or frequency shift keying or phase shift keying, which is called a digital modulation. Please note that again, data is not transmitted directly. Only you are transmitting high frequency carrier. What is carrier frequency? In ZigBee, it is 2.4 gigahertz. This will be 2.4 gigahertz. Very high frequency. Correct? That's why in your vehicle to vehicle communication, antenna is like your cell phone, invisible, very small antenna, few centimeters. Okay. Before I forget, there's a relationship between, note down, between the formula, correct? Why you are doing modulation, already told. Wavelength of the carrier, which is we are transmitting, modulated carrier, lambda equal to C by F, where F is the frequency of the carrier, whether it radio or this one, if you modulate. Original signal you need not to, original signal is automatically overriding in the carrier. So F, C is the speed of light, okay? So we know that it is nothing but 3 into 10 power 8 meters per second, correct? Or 3 lakh kilometer per second, okay? Meter per second, okay? Lambda is in meters, okay? Then, and this is for wavelength, radio frequency wavelength of the carrier, radio frequency wavelength. That depends upon frequency, the frequency of the carrier. What is the relationship between receiving antenna? What should be the minimum size of the receiving antenna? Minimum size, note down. Antenna, minimum length. I'm not a thickness and length. It can be thin wire also. But only it has to be stiffer to stand. I can call this as L. L equal to lambda by 4. Correct? Lambda equal to C by F, where F is the carrier frequency. Amplitude modulated or phase modulated or frequency modulated carrier, that carrier frequency is F. I already told you, if I say that my radio station, correct, frequency is 1000 kilohertz or 1 megahertz. Again, for complete name saying, lambda equal to 3 into 10 power 8 divided by 1 into 10 power 6. So many meters should be the length of the single cycle of carrier. Okay. What should be my, this is broadcasted by the broadcasting antenna. It can be bigger also. Radio station, TV station can be 100 meter also. Correct? Now, what about the receiving antenna? For good quality reception, receiving antenna length L equal to lambda by 4. You can calculate. Now, in case, so same thing for any radio communication, transmitted carrier frequency no, then C divided by that will be the length of the L, lambda. Lambda by 4 should be the minimum length of the receiving antenna for good quality reception. Minimum. It can be bigger, but at least it should be 1 lambda by 4. Okay, you can calculate. Okay, in case of our this one, cell phone, this one, we know that the lambda equal to 3 into 10 power 8 divided by 2.4 into 10 power 9 meters. Correct? You can see that Zigbee. See, this is Zigbee model available from Arduino. You see the length of the, you see here, few centimeter, 2 centimeter, 3 centimeter. This is the receiving antenna in Zigbee. 3 to 4 centimeter only. You can see physical. This is physical photograph. I have 4 or 5 in my lab because we are working on it. Correct? 3 to 4 centimeter. A conducting wire. This is connected to amplifier. All those things. Demodular. Everything is inside. One single IC. So what is then this length of the antenna equal to lambda by 4? You can calculate and find out. It will be few centimeter. 2 centimeter, 3 centimeter. That is sufficient for receiving Zigbee from another this one quality. That's what we wanted. Okay. Now, let us continue with this. Here, it is a license-free device in ISM band. Okay. The frequency is 2.4 gigahertz. Low channel bandwidth is 1 megahertz. It is restricted to wireless personal area only. Okay. Zigbee is used for inside a building. Correct? Need not to be in cell phone also. There's no Bluetooth. Cell phone you have Bluetooth, but the Zigbee is used inside lab. While I want to transmit, you can use it also. what is the maximum range it can work? ZigBee only maximum 30 meter generally. It can go maximum 50 meter. Please note that the amount of the power you can transmit through ZigBee antenna is fixed by FCC. It cannot be more than 30 meters. Generally, it can be few meter plus or minus. So the amount of power developed by ZigBee system such that the range of this will be in the order of 30 meters only. So it is called short range communication. It is called as short range communication, radio communication. ZigBee is used for short range communication. We see the 50 meter, 30 meter maximum, maybe 50 meter. Okay. Target rate. The ZigBee best quality is low power consumption. It consumes very small power. The amount of power it can consume is in milliwatts only. Why? My range is few meters. If I wanted to, I told you, my FM radio station power, go to the FM radio station, maybe kilowatts. If you go to shortwave radio, Delhi, and Delhi station you can receive. What is the distance between Chennai and Delhi? 2000 kilometers. I can receive shortwave radio communication. That the transmitting power is megawatts. That's why I'm able 2000 kilometers. I'm still able to receive. Correct? BBC is transmitting. Voice of America is transmitting. They have this one in Sri Lanka. Correct? Sri Lanka and this one they have a transmitting antenna. But actual broadcasting is done from the Washington. From there it is transmitted. This one now it is coming. For last 30-50 years they are transmitting. Correct? You can your radio you can listen to BBC radio. Washington, correct? Voice of America, correct? Australia. Because I heard all this thing in my village 50 years before, correct? The antenna is broadcasting station is Sri Lanka or Diego Garcia somewhere 1000, 2000 kilometers away. There they are transmitting megawatts power. But in case of this is ZigBee vehicle to vehicle communication, I want only few meters, so the power will be in the order of milliwatts, hundreds of milliwatts, or maybe a 1 watt. Correct? Power consumption, so you can use battery. Correct? If this is consume a lot of power, what will happen? Your vehicle battery will just quickly drain. Correct? ZigBee is used for even sensor network, wireless sensor, monitoring the rainwater, all these things, remote sensing. Correct? Rainwater, moisture, temperature. Inside IIT, the 600 acre. I wanted to monitor what is temperature in different location. I can use ZigBee communication. I connect this one. For example, thermocouple. Correct? It measures temperature. It can transmit this up to 50 meters. So every 50 meter one I put, they will be transmitting data. I collect that and send it to this one. Okay? So you can use. Then what is the transfer data rate? 20 kilobits per second, maximum 250. Note down. What is the canvas speed?
It is 1 mega. In
19 kilobits per second.
No, that was this.
40 up to 40 meters. I think it's 1 megabyte. If I'm not wrong.
1 megabyte up to
40 meters.
Meters of the 125 kilobytes.
Yes.
Okay. 19 was this one. Lin communication is around 1920. Okay. Here you can see that are wired communication. In wireless communication, the maximum speed in ZigBee is 250 kilobytes only. That is maximum allowed, which is lower than Wi-Fi. We are going to see Wi-Fi. Note down these important points. Okay. So then can have 100 nodes in very close. Right? Again, you can have multiple units like this. Multiple nodes, because later we are saying that if I want to transmit the data from one location to another, the range, what is the range? I am saying 30 meters. Correct? For example, I told you I want to monitor the temperature inside IIT campus using ZigBee. Please note that ZigBee is only a transmitter, wireless transmitter. I attach one sensor. Which sensor? One thermocouple, TC. Like that, I put some 100 different locations because 600 acres. I want to receive it. Correct? Thermocouple is measuring temperature and broadcasting the temperature in a particular location. Like that, I put some 100 units. So we know that 600 acre means it is from the IIT center to one end is 1 kilometer. At least other end is another kilometer. North to south like that. East to west is 500 meters. That is a long strip. And we know that only 30 meters I can know. How I want to collect data from this one to my lab. What I do is, we are going to see that you can form a network. Zigbee system can be networked. So how many you can connect? 1,000 nodes network connected as one single network. We'll see how it is. Correct? Maximum allowed number of nodes in a Zigbee network is 1,000 nodes. That is very good. Okay. Zigbee architecture. As I told you, Zigbee is a network communication. Okay. You can form a network also. Zigbee system structure consists of 3 different types of nodes or devices. Note down. One is called Zigbee coordinator. Other one is called router. Other one is end device. Okay. Then please see this figure. This is a Zigbee network, I told you. Okay. I have, this is one node. This is another node. That means one Zigbee device. Okay. Which can transmit data. And these are this one Zigbee nodes. How many nodes I have in this network? I can say 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 nodes forms one Zigbee network. And each can be maximum. What is the distance between these two? Maximum 30 meters only. Because they want to communicate with each other. Because they formed a network. Okay. So maximum distance is 30 meters. Worst case, sometimes little this one, I can maybe plus a few. But officially only 30 meters allowed. Okay. So I have connected forming this one. What I connected? Different device. One is measuring temperature. I told you Zigbee is not only used for vehicle to vehicle, it can form wireless sensor network. Correct? Measuring temperature. Correct? Remote sensing. Temperature, humidity, wind velocity, weather, this one, all those things, no? How the weather forecasting is done. They use Wi-Fi, Zigbee or this one to collect data. So they form a network. Okay. Zigbee forms a network communication. Okay. There are 3 types of devices are there. So those devices are shown in different color. Zigbee coordinator means it is shown as a red color. Okay. Please please note, in a network, there can be one coordinator only. One device can, in your class, I said Aruna Sonam is your class representative. He is also student only. Please note that he is student among the 24 students. But I given additional work to him. Correct? It is additional burden only for him. Whenever I talk all this thing, but he took a responsibility, took it. So, but I say that you are class leader. Correct? Similarly, in the network, I say you are coordinator. Correct? So some incentive to take some little extra work, give some name, big name, something. You are class leader. He will feel proud, so that the burden he will not feel. Similar to that, here all nodes are they are transmitting data. Correct? One node is given additional work. For that, you are given a name. You are coordinator. You are the boss. We say boss, people feel happy. Correct? So they said Zigbee coordinator. The electron device is not going to feel, not a human. I'm just saying. Please see that they call it as Zigbee coordinator. What is job? It collects information coming from other nodes. Also, you may connect one device also. You can connect one temperature sensor also if you want. Correct? It can work as one of this one. And all the data coming from all the nodes are collected. Please see that data is coming like this. And finally, that will be transmitted to the network, to your computer. From this network, I may send through Ethernet or internet. I want to collect temperature, send it to Delhi. Correct? IIT temperature, I want to measure, send it to somewhere, Delhi. Correct? What I do, I put my sensors collected, and the coordinator collect data from everybody. That data is coming to my computer. From my computer through internet, I'm sending to Delhi. Wireless, anything I can do. Correct? So this how the Zigbee. The next one is called router. Okay. Then third one is called end device. End device is because you say end device I connected to because I want to measure battery voltage. Correct? I want to measure battery voltage. That the information should be sent to Delhi. Correct? And another device is TV. I want to measure some TV information, something about TV status. Correct? Is power consumption something. and I want to transmit wirelessly to this one. So first thing is from the TV, the temperature measured and given to the Zigbee device close to the TV, correct, which is connected to this one. Then this Zigbee device transmit wirelessly to this node, correct. So it comes to this one. Then similarly this one, correct. Each device is measuring something. This device is measuring something, sound wave, something like something. Okay, all these things are collected and data is coming. And then please see that the end device is two end devices are connected to one router. Router means who is channeling, correct? So what is it? You collect data from these two nodes, correct? These two nodes are sending that because these two devices are very close. Please note that these two 30 meters, this is 30 meter, different location. So close to this router, the router collects data, sent to another router. Similarly, this router also, please note the router receive data from another router, also from another node. Okay. Similarly, this node send data. This data comes to this router. This router send data to this. Please note that this router doesn't have any sensor. Please note that I told you the end device definitely will have some sensor. Correct. End device are going to have data. Correct. The routers generally may have data because correct or just collect the data, send it. So this collect. Finally, this router sends to this coordinator. Coordinator collect data from all these people, send to internet, goes to next. Correct. So the whole thing is called Zigbee wireless architecture. Any doubt? Okay. Now we know that now that we have three type of in a Zigbee node, you can have three type of nodes: coordinator node, router, Zigbee together form a network. In a network, you may have all three type of devices. Right? Depending on how many devices can be there, up to 1,000 devices. In a node, up to 1,000. This is one device. That device can be our node, Zigbee node. That Zigbee node can be end user node, or router node, or coordinator node. But in a network, please note that there can be only one coordinator, but routers can be many. Correct? I say that there's one class representative. Correct? In my school we had. Correct? I was class representative when I was studying. There will be two assistant class representative. Two. Correct? To assist the class representative. And the class representative talk to the class teacher. Correct? Any assignment, something, all those things, collecting all those things, there will be assistant class representative. That is similar to this routers. And they cannot directly go and talk to teacher. They have to give to only router. Same thing only. Correct? This is what we do. Correct? In your party structure, you have president, vice president, correct? MPs, MLAs, then party, this one lower level, last cadres, finally voters, no, like that. Correct? So hierarchical structure, they call hierarchical structure. Okay. So what is job? Okay, every Zigbee node must consist of at least one coordinator. That's what I told. There has to be one coordinator. Okay. One coordinator has to be there. Okay. And acts as a, what is job of the coordinator? His job is act as a root node. So this is the root node. Each one is called node. This is root node. That means everybody should be connected to this one only. They cannot, other people cannot talk to outside world. So that's why they called as coordinator, called a root node. Okay. Then it performs receiving and transmitting data operation. Data is received from other nodes and transmit to the outside world. From outside world, also reverse also possible. Only this fellow can do that. That is second job. Correct? Receiving and transmitting data from other nodes to outside node, this one both way. So these people cannot send anything outside world. Okay. Then third is the coordinator responsible for handling and storing information. Correct? Now these people are sending temperature data. This data. Now this should be sent to Delhi. Correct? So now suddenly this internet is not working. Please note that this is wired network. From the coordinator node to my computer, it is a wired communication. For example, CAN bus or LIN bus, something like that. Or internet, wired internet. Okay. So suddenly this fellow is not working. Correct? But I am collecting data. I should not miss data. What happens? The data coming from nodes will be stored in the coordinator. That is job of the coordinator. Correct? I say that I gave the assignments, correct, to all of you. So I tell that Arnasolan should collect all the assignment and give it to me. When? On last day. Correct? Today, the Vikas is giving, Prabhakaran is giving. Next day, Rahul is giving, Valis is giving. Next day, Prem is also like that. So I say that if every day our Arnasolan giving, I say no, because I have some work. That's why I given a class representative. What is your job? You have to collect, storing information. Collect the assignment. As and when it collects, that means data coming from different nodes will be collected by the Zigbee coordinator, correct, and transmitted to the network, to the next higher level. Suppose this network is not available. See, generally, if we can say real time, the data transmission can be real time or offline. Generally, we want real time. Vehicle to vehicle communication, all this one, we want real time. As and when data should come. But suddenly something goes, still the data should be stored. That is job of the coordinator. Note down, these are three important jobs of the coordinator node in a Zigbee network. Then Zigbee router, what is job of the Zigbee router job? Okay, the router acts as intermediate device that permit data to pass to and fro from the other devices. From here, correct, two-way communication. Correct? It can send from the, there is nothing but these nodes, end nodes, correct? Well, you know, end devices, we call end devices, which is shown in green color. Job is to get from this one or from other routers also. Please see here. This is one router. This router is receiving from this node. I am circling. Please see it. Correct? From here, this router is receiving data. Then this router is passing to another router. The data may be from the end device or from other router. Those data should be collected and sent to the coordinator. That is job. Please know that coordinator also can receive data directly from the end device also. Correct? For example, I said class leader to assistant class leaders. There are 100 students. I say assignment can be given to class leader or assistant leaders. Student can give it to assistant leader, or sometimes if they see class leader directly given. That's what I'm saying. The student can directly, end node can directly send it to coordinator, or it can send it to a router. Can send it, these two router can send to this one, and finally it comes to here. Correct? That's what. So the job of the router is collecting data from end device and sending to coordinator, or from other coordinator. Other router to another router, and finally to coordinator. Okay, so that's this one. Then what is the end device job? End device have limited functionality. As per Zigbee network is concerned, his job is very simple. Correct? Collect the data from the sensors. Collect the information from various sensors. Correct? These are sensors. This is sensor. This is sensor. This is another sensor. Here we are measuring temperature. Here we are measuring voltage. Here we are measuring something else. Here there's a TV camera, correct? And this is some other device, correct? Some calculator device. These are connected. These devices are connected to this Zigbee node, correct? These devices are sending digital data. These devices are sending digital data. All the devices are sending digital data to the end device, which is the return. Then there it does the modulation. Please note that Zigbee also has a modulator. It is a wireless communication device. It has a modulator inside. The data coming from the device will be, digital data will be modulated like this. Correct? It may modulate. This is digital data. This is the carrier. Carrier is generated inside each Zigbee device. There's a carrier generator is there. And the data is coming from sensor. So then modulator may do this, depending on what type of modulator it is. FSK, ASK or PSK. Depending upon that, it will do. This is what is transmitted wirelessly by this antenna. This antenna is going to transfer FSK or ASK or PSK only. Correct? So the sensor is connected. There is a carrier generator. There's a modulator that is transmitted. Everything is happening inside Zigbee device. This device costs only 500 rupees. Because Arduino Zigbee device cost 500, 400 rupees or 1000 rupees only.
Sir, one query.
Yeah.
Just a practical example based query. So I understand that Zigbee can be used for some home appliance,
Yeah.
smart home creation and all.
Yeah. Yes.
So for instance, if I am having a smart home connected with IoT devices and there is one phone app with me, and there is another person in my house who has the same phone app, and we are trying to control the same, say for example, you are trying to switch on one fan or control the thermostat or something.
Okay.
At the same time, if you are trying to operate and there is a Zigbee central router or something or a coordinator that is there, right? How will this signal be processed? Like,
Yeah. First thing is you need to communicate with the Zigbee device, not to your end device.
okay, understood. So the app will communicate with that Zigbee device, and then only it will ensure that it goes to the end device.
Yes.
Okay. So if multiple people are communicating even at the same time, it will ensure that. How will that happen?
See see that means you need a multiplexer.
Okay. It will have some any priority based this thing. For example, if one person is trying to switch on the fan and another person is trying to switch off the fan, so how will it ensure that this operation is only carried out and another is delayed like that?
Well, see, because you are please note that this is your Zigbee device. Zigbee device only is a receiver. Finally, you will go connected to a microcontroller. Data is coming here. Zigbee doesn't control directly. Its job is receive data, decode and send the data to a microcontroller. In the microcontroller, connect one is to fan, other one to another device, home device, for example, washing machine, something. So here you have to write the program which will control. In the Zigbee, you are going to transmit data from your wireless device to this device, and when you transmit, this receives, and whatever the data comes here, it goes here. The microcontroller decides based on the command what it is receiving. You have to program this microcontroller.
Understood now, sir. Okay, thank you.
Okay. So the final device is part 5 actually connected to actual sensor or whatever it may be, correct? So then what are the functionality? It has limited functionality. It will not coordinate. It cannot do that. It cannot get the data from another device. So this way you cannot connect, because you are told this is end device. Because the Zigbee device, you program it, whether it has to be a router or a end device or a coordinator. This device also you need to program. Only 3 devices. Once you program a end device, you cannot communicate like this. Correct? So that's why he said that it has limited function. It can go to many times. These devices can go to sleep mode. Correct? To save the power. Now it is connected to a sensor, and whenever the sensor sends the data, that time alone it will wake up, because these are wireless sensor, because the power is wasted. Can communicate only with router or coordinator. It can, 2 end device cannot communicate each other. That's what important, no doubt. Okay, then many wireless technique can be used. What type of this one we'll talk about when we find type like that. The number of routers, the coordinator, end device depends upon type of the network. Okay, then type of network, there are 3 type of no doubt. One is called star type network, other one is 3 type network, third one mesh type. In a Zigbee communication, the wireless network can be formed in a star fashion or a tree fashion or a mesh fashion, no doubt. So let's stop here. We'll have next class Monday. I think time is 6:45. We have to go. So we'll have another 3 classes next week. That'll be over, because we have to cover this. After that, we have the path planning.
Sir, self-study time also.
When is your exam?
Sir, 6 and 7 is too close now.
Okay, I will do one thing. this wireless communication, Monday we'll have the class. We will complete that day. Path planning, I will send the notes, PPT, self-study. No, you tell. I can teach, or what is that you want?
There's no issue, sir. You can teach us. We enjoy it.
Otherwise, we can do one thing.
Yeah.
Tomorrow we can have one class. Monday, last class, close.
Yeah, sir. Fine for me.
It's okay, sir.
It's okay, sir.
No.
Okay.
See, but Monday is Christmas holiday. That's why I don't want to have the class. No, you tell. See, I will teach 2 classes. That means each class 2 hours, totally 4 hours. When you want to have, I want to close. Anything remain, I'll send you as notes.
Sir, we'll discuss, sir. Arunachal will communicate, sir. No problem.
Okay. You tell 2 classes when you want to have. Tuesday, Wednesday. That means 3-day holiday, enjoy, including Christmas. Or tomorrow on Sunday, complete. Next week, free. After that, free. Or whichever way, Arunachalam will communicate to me by tomorrow or this one, tonight. Accordingly, will do.
Sir, only one request I have.
Yeah, please.
Probably that will make you angry again. But
I won't get that for my student. Why?
Sir, basically,
if I get angry, then I am not a teacher.
no, not like that, sir. Because you have already answered this question too many times. So again, I'm repeating it. Sir, basically, the syllabus is, I would say, is huge in that way for the final semester. So if you can just indicate the weightage wise, that will be great for us. Nothing on that.
I will do one thing. See, up to midsum, right? See, I am going to set question paper for 60 marks. Right? Up to midsum, it will be for 20 marks.
Okay.
After that, 40 marks.
That is a great help, sir. Thank you so much.
Okay. 20 marks up to midsum. Remaining. No, what was the midsum? You just tell that.
It was up to cruise control.
After that, what we covered, you tell.
After that, we have covered adaptive cruise control. Then we have covered LW lane
Radar.
radar.
LiDAR.
Then LiDAR,
Sonic.
and then LW lane departure system. Then we have image processing, like inverse mapping of inverse perspective mapping,
Half transform.
like different algorithms that we have used in that way.
Tell one thing. Yeah, 20 marks for before midsum. Up to midsum, 20 marks, 40 marks after that.
That is perfectly okay, sir.
Is okay? Everybody. Okay. Whatever Rahul, Prabhakaran, Vikas, class representative, he has to give his permission. Very important for me.
This is okay, sir.
Is okay?
Yes, sir.
Or 15:45.
Sir, 24, I would say 25, 35 is okay.
20:40.
Okay, sir. Fine.
Okay.
Right, sir.
Okay.
Perfectly okay, sir.
The next 2 classes, each 2 hours, your class representative, whenever he says, that day I will teach.
Okay,
No,
sir.
next 2 classes, when? Whether it is Monday, Tuesday, or Tuesday, Wednesday.
Sir, we'll let you know, sir. Just discussing.
Yeah, discuss. Saturday, Sunday, we leave. Enjoy, but already 5 days you work. Right? Today also up to already 7 o'clock. Monday, Tuesday, or Tuesday, Wednesday. 2 days I will come close. You tell. Accordingly, we have the class. Okay.
Sure, sir.
Thank you, sir.
Sure, sir.
Also nice.
Thank you, sir.
Thank you, sir.
Bye.
Thank you.
Same to you, sir. Thank you.
Thank you, sir.